Most of us interact with AI like it's a digital vending machine. You put a prompt in, you get a single answer out. But a one-off response hits a wall when a task requires a multi-step project that unfolds over days or weeks. You cannot build a functioning website or draft a complex legal brief with a single prompt. Standard chatbots lack the internal architecture to track their own progress or correct a mistake they made 3 steps ago. They operate without a mechanism for long-term self-evaluation. To bypass this limitation, computer scientists use a structure called the AI agent harness. This takes the linear path of a standard prompt and forces it into a continuous closed loop. Achieving autonomy requires this shift in geometry, moving away from a straight line toward a self-correcting circle. Before the loop can begin, the harness must establish 4 technical parameters. These provide the system with its memory and its boundaries. First is conversation history, noting previous data logs. Second, the system identifies available tools to affect the outside world. Third is working memory, a short-term space for evaluating active thoughts. Finally, the harness sets stopping rules, defining when the loop terminates. Without these 4 pillars, an AI lacks the context and tools necessary for targeted autonomous action. Once the parameters are set, the system enters the outer conversation loop, a repetitive cycle of 4 distinct phases. In observe, the system scans its environment. During think, it calculates the next step. In act, it executes the decision using available tools. Finally, check measures results against the goal. This metric instantly becomes the new state for the next rotation. Autonomy emerges when this feedback loop executes thousands of times per minute, with each rotation building on the last. A loop this fast would consume infinite computing resources if it were allowed to run without a termination protocol. To prevent this, the agent harness is programmed to break the loop under 2 specific conditions. The first is a successful termination. This happens when the system verifies that the stopping rules have been met and the task is complete. The second is a handoff. If the system encounters a roadblock beyond its available tools, it stops the loop and requests human input. Engineering efforts are increasingly focused on the resiliency of these loops. By refining how an AI observes and checks its work, the system becomes more reliable over longer durations. Autonomous task completion is the result of this structured, high-speed feedback. It is a process of observing, thinking, acting, and checking until the work is done.